Hey 8th graders, this is lesson 4, session 2 in your book, which starts on page 87. So yesterday for session 1, you were just looking at what is a dilation. You know, the shape gets bigger or the shape gets smaller. That's a dilation. But now we're going to develop our understanding a little bit further and include what we know about scale factor. And our essential question is, what does it mean for figures to be similar? So keep in mind these figures are not congruent, they are similar. Our first model here gives us a clue right in the title. We're going to look at the size and the shape. Okie dokie. So figure S is dilated to form figure T. S is here, T is there, and it says the scale factor is 1.5. So that means it's an enlargement. It's gotten bigger. If the scale factor is greater than 1, we're getting bigger. We are enlarging. If the scale factor is less than 1, we are reducing, getting smaller. So this one is greater than 1, we are enlarging. And it's going to ask us two questions down here. How are figures S and T the same? Well, they look like the same shape, right? They look to be the same shape. Let's put that down. They look to be the same shape. Oop, that's not how you spell look. There you go. It's got a K in there somewhere. They look to be the same shape. And then how are they different? They're not the same size, right? That's pretty much all there is to it. They're not the same size. I'll put T is bigger than S. And that's really all there is to that. That's how they're alike, that's how they're different. Dilation is, the shape is similar. The only difference is the size. And it says right here what I just said. Figures that are the same shape are similar. Two figures are similar if you can map one figure onto the other by a sequence of one or more transformations. Figure S and figure T in problem 1 are similar because you can map figure S onto figure T using dilation. So if you were to multiply, the distance between point A here and this point by 1.5, you'll get this point. They're similar. And the math symbol for similar is this little squiggle line right there. Similar. We did congruent for rigid transformations, but these are not congruent, they're just similar. And it asks us here, is figure T similar to figure S? How do you know? Well, if we look at our definition up here, it says two figures are similar if you can map one figure onto the other. So you can map S onto T if you enlarge it. Ta-da! Okay, now all you got to do is look at number 3 here, and you choose two figures that appear to be similar and write a similarity statement. Similarity statement just means use this right there. Use the similar symbol. So let's see, which ones look the same? No. No. Oh, there we go. Right there. And right there. That looks like the same shape, doesn't it? Well, in that case, I'm just going to put A is similar to D. That's all you got to do there. Okay. Now we're going to look at the corresponding parts more specifically and get a little more mathy in here. So, figure DEFGHI is dilated to form similar figure D prime, E prime, F prime, G prime, H prime, I prime. So let's see, that was blue is the original, pink is the new one. The scale factor is 1/3. Remember what I said about scale factor? If it's less than 1, that means we are reducing it. We're making it smaller. So the we're going from bigger to smaller here. Okay, and the center of dilation is X, so this is the center of dilation right there. Side DE, let's get out my green here, side D prime E prime corresponds to side DE. Oh, they're named similarly. Isn't that convenient? The quotient of their lengths. Now, if you don't remember what quotient means, I want you to write yourself a reminder in the corner. Quotient means answer to a division problem. You must know that word forever and ever and ever. Answer to a division problem. Just like addition, the answer is sum. Subtraction, the answer is difference. Multiplication, the answer is product. Quotient, the answer is called, no, division, the answer is called quotient. What am I saying over here? So don't forget that. Okay, the quotient of their lengths can be written as D prime E prime over DE. And looking at the lengths here, it is 4 and 12. So they've put here 4 over 12. Write a fraction for each of the other 5 pair of corresponding side lengths. Okay, so let's do some counting here. We've got E prime F prime. That is, oops, I need a pen here. E prime F prime is 1, 2. And then EF is 1, 2, 3, 4, 5, 6. 2 over 6. FG, let's see, FG is 1, 2, 3. And then proper FG, not FG prime. F prime, G prime. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, G prime, H prime now. 1, 2, 3. Oops, that's the opposite. That's the bottom one. Shame on me. This is GH. That's 1. Oh, look, 1/3. Does that look familiar? And then H prime I prime is 1. HI is 1, 2, 3. Oh, look, another 1/3. And then D prime I prime, 1, 2, 3. And then, nope, I did it again. 3, 1. There we go. Don't forget, put the one that says on the top on the top. Don't be like me and put it backwards 3 times in a row, for heaven's sakes. Okay, what is the relationship between the quotients of corresponding side lengths? How does this compare to the scale factor? So you may have noticed that this one, and this one are the scale factor, and this one and this one reduce to the scale factor. If you reduce 2 6 by 2, divide by 2, divide by 2, it's 1/3. You can reduce this by 3, and it's 1/3. All of these are equivalent to 1/3. Let's put that down. The fractions are all equivalent to 1/3. That answers the first part of the question. The second part of the question is, how does this compare to the scale factor? 1/3 is the scale factor. Silly. Ta-da! How do the measures of the corresponding angles compare? Well, let's look at them. We have a 90-degree angle here and a 90-degree here. A 90-degree here and a 90-degree here. They're all 90-degree angles, aren't they? Let's see, how can we word that? They all have the same measure. They have the same measure. In fact, all the angles in these have the same measure, but the corresponding ones are what we're looking at, right? These two correspond, for example. Okay. What is the relationship between the corresponding side lengths and the corresponding angles in similar figures D, E, F, G, H, I, and D prime, E prime, F prime, G prime, H prime, I prime? I'm going to get out my text tool for this one. Type it out a little bit faster. Okay. So the corresponding side lengths, they're not all the same. They're similar. So, but they're all congruent to the scale factor. They're all proportional to the scale factor. Proportional. That's the word we want. So the corresponding side lengths are all proportional to 1/3. I'm going to make that a little bit bigger for us. Give me a second. Okay, and then the corresponding angles, now those are not just proportional, they are exactly the same. So the corresponding angles are congruent, they're the same. You don't have to put the same if you remember what congruent means. I just want to be sure you remember what congruent means because it's an important word. Okay, number 3. I forgot I already did number 2 since it looks so nice and tidy all typed up. Number 3, describe 2 ways you can tell figures are similar. Well, what were the 2 ways that we just did? Didn't we just do 2 ways? Right here and here. Well, let's write those down again in a different way. So, let's see. I'll put it in my text tool again. If the corresponding sides are proportional and the corresponding angles are congruent, then the figures are a dilation of each other, which means they are similar. Okay, I'll change that color because now it looks like it's part of the whole thing. Hang on. That's better. Now you can tell I wrote it. Label the center of dilation. This is number 4. Label the center of dilation for triangles XYZ and X, Y prime, Z prime. Ooh, well, you may notice here that the X didn't change. It's not X prime. It's still X. So the one that doesn't change is the center of dilation. So we labeled it right there. Then we're going to write a similarity statement. So all you have to do is write the names of the triangles. And then use your similarity symbol. And that is it. Now for these green pages you are on your own, but let us know if you need anything.